There is a clear need for a reliable and repeatable way to measure joint range of motion in therapy. Current tools like manual goniometers and visual estimates often lack consistency and accuracy. To address this, our team is developing a precise joint angle measuring device with an intuitive interface and secure attachment system, giving clinicians and patients a tool for accurate assessment, efficient documentation, and clearer feedback on rehabilitation progress. In our ethnography, we spoke with clinicians working in various settings, including physical therapy offices, hospitals, and emergency rooms. We found an unmet need for simple, accurate, and reproducible joint angle measurement in clinical practice. We also observed traditional goniometers in use. While standard, results can vary depending on the user and patient movement, reinforcing the need for a more reliable solution.
From our early planning sessions, we focused on identifying the engineering requirements and specifics that would guide our design, specifically our key activities, key resources, value propositions, and minimum viable features. Our design process began by addressing the inconsistency of traditional goniometers and the need to work across different joints and body sizes. The first concept used removable, adjustable Velcro straps that wrapped around the limb, one above and one below the joint. A goniometer-like arm with a central hinge attaches to these straps, allowing adjustment for different users.
Another of the prototype designs created included a goniometer attached to a sleeve that could be slid on to the patient's knee or elbow and be positioned correctly after being on. The device would then stay in position while being used and can be taken off and reused. This concept focused on a brace-like structure that provided a more rigid stabilization, which helped us think about how to reduce measurement variability during movement. We landed on a design that incorporates digital outputs with Velcro strap adherence, which allows for use among a broad range of patients and a more intuitive user interface.
We began with simple prototypes to test the core features of our design and identify early challenges. These initial builds allowed us to perform killer experiments to quickly evaluate the device's form, function, and usability, highlighting areas that needed refinement before moving forward. We aimed to design a device that was intuitive to use, to the point where a patient could reasonably be able to operate it on their own. This would open up the opportunity for a patient to use the device in their own home outside of physical therapy appointments, to track their own progress and report the measurements they read to the physical therapist at their next appointment. With the attachable device, clinicians are able to view the joint in the desired position and immediately record the measurements. The joint being adhered properly to the anatomy of the patient reduces placement error and improves accuracy and consistency of results.
Moving forward, we hope to integrate digital angle sensing, refine our attachment system, and finalize an engineering prototype for testing in the next phase. Our team looks forward to presenting a fully validated device at the final Senior Design Exposition.